So after splitting the mesh regions, we would definitely say two separate zones or two separate regions, which is named water and air. That is corresponding to our definition here in the blocks. We explicitly name it as water and air. Compared to the previous setting, we only use a solid region for it, and the default fluid region is named by domain 0 and domain 1. So this operation actually change all the three folders we have copied before. So in the system folder, so we have previous domain 0 and 2, right? And now domain 0, 2, and solid is of course from a previous one. Now we have the air and water. So and also the constant and the 0. So what we can do now is we need to process the three separate folders and try to delete all the previous meshes, but copy out some previous settings. So let's go to the system folder first. The system folder is really about the solution and the integration scheme. So that we want to copy to our air. I'll replace them here, and also the water. So these are the main for the system folder. For the other two, domain 0 and solid, actually I don't need it, and then I just delete them. Okay, and that is system. Let's go. So that what I did here. I will show the result later. And now we go to the constant folder. Still remember what we did in the constant folder. We need to define the region properties. So the region property is still from previous. We have the solid, domain 0 and 2. Now we only have air and water, right? And we don't have any solid, so we make it a black. So that's what we did for the region properties. And gravity, we didn't change it. And now we should copy out some previous settings to our new meshes, domains, air and water, because we only have the mesh information, but we also need to define the thermal properties and turbulence properties, right? So if you still remember, domain 0 is actually for water and domain 2 is for air. So let's start from the domain 0, which is water, and I just copy the turbulence properties and thermophysical properties to my water region, and that should be fine. And also the domain 2 is for air, and I only copy these two to the air domain, and I don't have any solid now, so I need to just to delete all these three, right, in the constant folder. So that would be fine for our constant folder. And now finally we go to our 0 folder. So again, 0 folder is mainly about the boundary conditions. So what we need to do is copy this, only the boundary. Domain 0 is for the water, to the water. And what we need to do, also copy the domain 2 is for air. And now all the three domains, previous domains or previous regions, is not valid to us. I just delete them. So now we have the 0 folder, but remember we have split the regions again, which means that the cell to region is pretty different with previous. So for here we have the water to air, but if you still remember previously, we only have the water to solid or domain 0 to solid. So what I need to do is change the domain to solid to water to air. So that's the interface actually what we want to do. So that's water to air. And for other water inlet, water outlet, bottom wall, front and back, still the same. So there's no any difference. So that's the U, and I'll then go to the P, and P is also just change it to water to air, right? Water to air, that's water to air, and PRJH, and also water to air, and finally temperature. So temperature here is water to air. All right, so water to air, and that's all. So water to air, we still have the interface to be defined, and what we need to do a little bit different is on the temperature, because in the temperature we need to define the interfaces, but also include the solid region in here. So in the air to water or water to air, we need to explicitly define the thermal properties. So in the water to air, I will copy this to the temperature. So that's water to air. So you can definitely see the difference. The difference is we still have this type, but we actually add extra properties, which is the thickness. So that's 2 mm thickness aluminum, and the copper layers is actually thermal conductivity, right? So that's what we need to add the virtual aluminum block to include this solid interface into our regions. So that's good for our water definition, and I need to do the same to the air. So I will check what I have in the CHT region for the air. So again, it may be different with the previous. I'll open it and see the difference by the two windows. Again, air inlet, air outlet, top wall, no difference. Front back, only the air to water. Here is domain to solid, so I need to change it to air to water, and P, air to water, and PRGH is air to water. And finally, we go to the T. So again, it is air to water, but also need to include the thermal conductive properties of aluminum. So I will copy this here and paste. So it's the same setting. Remember, it should be the same setting, the same thickness, and the same kappa, which means the thermal conductivity for the interfaces. And that is main definitions for our 3 folders. And I think we are nearly ready to run the solving process.